Hello, welcome to the presentation on lbtelephony, which is low bandwidth telephony, part of the Bluehack project. Essentially, the idea behind this application is to reduce the telecom data flow bandwidth by 1/12 on an average by applying cognitive technologies to transform the audio to text and transport the further compressed form of the text over the network. The architecture and topology. lbtelephony makes use of cognitive capabilities of IBM Watson and Alchemy APIs to achieve this bandwidth compression effectively. A better term we coined for this is cognitive modulation. Written in JavaScript and hosted in Node, these applications make use of Express module for improved web server development and execution efficiency, and Multer module for efficient file upload operations. A number of other helper NPM modules also feature in the application. We tested this with Google Chrome browser. The user's input, which is in the form of an audio file, is first converted to text through speech-to-text service. Entities and keywords from the text are extracted through the Alchemy API. The converted text is then compressed using zlib compression library. This compressed data symbolically represents the essence of the application. The text is then synthesized to retrieve the original speech back through the speech-to-text service. This audio is further transmitted to the receiver. The same browser which initiated the input receives this output and renders it in an audio player for the receiver to consume. Alright, now let's run this application. What we see in the left hand side of the page is where we give the audio input to the application. For the user's convenience, 3 predefined audio files are provided, as well as an option to upload a custom file for user's choice. Let's pick up a simple text now.
Hello world, I am Watson.
Alright. Now let's upload a custom file. Ideally, we would want to have a live chat session between two users with proper full duplex, interactive and real-time conversations between them. Why we did not attempt such an implementation and instead limited to a symbolic representation such as this is because of multiple reasons. One, currently Watson services are hosted in Bluemix, and the latency of availing the speech-to-text and text-to-speech services for a real-time conversation is unacceptably high, and it can break the continuity of the conversation. In real scenario we propose, where the service is hosted in one of the service provider's cloud, this limitation will be avoided. And secondly, a live chat session requires quite extensive code which is related to management of data flow and the user sessions outside of the underlying transport mechanism. This may skew the importance of the application towards the chat logic, etc. So we felt it is prudent to implement the code of the compressed transportation technique and propose the rest as enhancement. Alright, let's hear the conversation now.
Hello victim, how is the direct bit taboo for related PMR going on? What is the latest status? Hello Nasser, the new proposed fix is being tested by the customer. So far they are positive that the garbage collection storm is avoided. Good, thanks for the effort on troubleshooting this complex issue as well as coming up with a comprehensive fix. I am sure this is going to resolve this long-standing PMR. Welcome. And thank you for your continued support and guidance. It has been a deep learning from me. I never realized debugging customer problems were so exciting. All right, talk to you in the office. Bye-bye.
One of the features which was mentioned in the abstract but not completed is regenerating the original audio quality of the speaker. This is something which we could not be completed due to the relatively short runway for the hackathon project schedule, and we wish to implement the same in the near future. Please contact me, Girish, or my colleagues for any queries, clarifications, or improvement suggestions on LB telephony. Thank you very much.